All right, let's do another example of internal forces. So here we're asked to find the normal force, shear force, and bending moment at point D, which I've already made our little squiggly line through, just in case it's not clear. And hopefully now you're getting the hang of it, that we're basically going to need to divide and conquer, right? So we're going to need to make our little section at the location of interest and identify what the forces are. And based on the example I've shown you already, hopefully you see that it doesn't matter which side of the free body diagram you choose. You can choose either side. Just pick the one that you think is easier for you to solve. So for example, we could look at this left side at D. If we split D, the beam up at D. And now we can even start to be a little bit more clever in our decisions and notice that we don't necessarily need to solve for all of the external constraints, right, if they're not really needed. So here we have By, the external 40 kip feet, and then of course we have our internal forces. So N, V down on the left, M, normal force that's tensile, shear pointing up on the right, and M. So you should always follow this exact same convention for the right or the left side. I kind of like the one on the right, so let's use that one for now. So based on that, we can go ahead and write out our equations of equilibrium for the right-hand side. Right. And we can see that our sum of forces in the x direction minus n equals 0. Sum of forces y, positive v up plus by equals 0. So therefore v equals minus by. So you know you need to solve for by for sure. How are we going to get that? We'll do a free body diagram of the whole beam and come back and get by. So why don't you pause, go do that, and then I'll show you my free body diagram. Let's make sure those line up, and then we can keep going. All right. So here's the free body diagram I have for beam by, the whole thing, and we know our goal is to find by, so we'll go ahead and take the moment at A, right? So the moments at about A, we have by, positive 24 feet, or positive moment, our external positive 40 kip feet, and then we have that minus 8 kip external load times 8 feet, its moment arm equals 0. Do some math. 24 feet times by equals 24. 40 minus 64, right? Yep. So this is going to end up being 24 kip feet. So by equals 1 kip. So therefore, shear up above, up here, is equal to negative 1 kip. And we know normal is equal to 0. We've already solved that here, just to point that out. And now how do we get our last step? Come back to the free body diagram of the right-hand side again. I think I have it set up. We'll come back here to this free body diagram again, the same one we've been using for these two equations, this one and this one, and now solve for the moment. So we can solve for the internal moment by just taking the moments at D. The only thing here is we have the by, right? And then this distance was 8 feet, right, from D to the end. So therefore that's our moment arm minus M plus the external 40 kip feet equals 0. We just solved for by as 1 kip. So therefore M is equal to 48 kip feet. So those are the 3 internal moments. Go ahead and squish this up. So we have N equals 0, shear equals -1, and M equals 48 kip feet. All right, let's do some more. So really this whole section for right now is just about practice. Give you a couple of different examples, and let's keep looking at slightly more and more complicated versions.